In this example, we have powers of secant and tangent. Notice that the power on tangent is 1/2, so we don't have a rule that incorporates that. The power on secant is even, and we do have a rule that will deal with the secant to an even power. So that rule says that we are going to pull off a pair of secants. So we will leave the tangent raised to the 1/2 power, and if we pull off a pair of secants, we are going to have 2 secants left over. So the ones here are considered the leftovers. And those leftovers need to be converted to the other trig function. So we're going to convert those over to tangents. So we have our tangent to the 1/2 power. And now we convert the leftovers. Secant squared is tangent squared plus 1. So we are going to replace secant squared with what it is equal to in terms of the other trig function. And now we are poised for u substitution. Let's do u equals tangent of x, which will have du equal to secant squared of x. So that is perfect. That allows us then to rewrite our integral as 8 multiplied by u to the 1/2 multiplied by u squared plus 1 multiplied by du. And if we distribute the u to the 1/2, we will have u to the 5/2 plus u to the 1/2, and we can now use our power rule. So that will be 8 multiplied by, let's see, add 1 to the exponent there, we get 7/2, dividing by 7/2, and then add 1 to the exponent here, we get u to the 3/2, we'll divide by 3/2, plus c. We will now convert back over to our original variable, and let's also deal with the constants here. We'll distribute the 8 and we'll flip those denominators. So we'll have 16 over 7, and then u is tangent, so we'll have tangent to the 7/2 of x, plus we flip over the 3/2 and get 2/3, and then we multiply by 8, we get 16/3, tangent raised to the 3/2 power x plus c. There we go.